In the past, we've worked on solving quadratic equations by completing the square. So what I'm going to do is I'm going to kind of walk through completing the square for a particular equation. And I'm going to do it side by side with all this algebra here that probably looks a little bit messy. But what it's going to be doing is just taking the same steps that I'm going to do as I complete the square, but do it for any number A, any number B, and any number C. That could be in those spots of my quadratic equation, the A with the x squared, the B with the x, and the C as the constant. So here's my made up problem here. 4x squared plus 24x minus 8 equals 0. Okay, so that would be something that's in this form. All right, so if I was going to complete the square, remember we like to get the constant part over on the other side. So I'd add 8 to both sides and make it look like that. But then I would also note that whenever we completed the square, we always had a 1 in front of the x squared. So because of that, I'm going to factor this 4 out. All right, and that's what they're doing over here. And then I could go ahead and divide both sides by 4. So then left on the left side here is just x squared plus 6x equals 2. All right. Now I would think about what do I want to add to both sides to complete the square? So I'd look at that middle term. So chop 6 in half and make 3 and square it to make 9. And that's fine as long as you also add 9 to the right side. And then that, of course, makes the left side turn into x plus 3 quantity squared, and the right side is 11. And then these other steps that you see here are just them taking their complicated looking right side and simplifying it into just a single fraction expression. Okay. But that's all just this same step here. But then what do we do at this point when we've got something squared equals a number? That's when we apply the square root property. Right, so we say x plus 3 is equal to plus or minus the square root of 11, which is what they did here. And then we finish by moving the 3 over to the other side, so subtract 3, and so then there's my solution after I complete the square. Well, these last few lines are just them once again just kind of taking all these letters they've got floating around and making it look nicer. But as a result of completing the square with A, B, and C as the numbers, this is what they get. So what that means is that we have now completed the square for any quadratic equation ever. So if we can look at a quadratic equation and put it in this form here, ax squared plus bx plus c equals 0, then what we know is that the solutions to that equation will have to follow this formula. And we call this the quadratic formula. Remember that completing the square will solve any quadratic equation, right? Whereas solving by factoring only solves equations that factor, of course. So since completing the square always works, and then the quadratic formula comes from completing the square, the quadratic formula will always work as well. All right, now as we go through these slides and do some example problems together, I want you to understand that I'm going to put the quadratic formula up here because if this is new to you, of course, it's going to take you a little time to memorize it. But understand you do have to memorize it. So I am not going to give you the quadratic formula on any kind of assessment. You need to know it. And that's because it's going to be something that you're going to use a lot as you proceed on to pre-calculus and to calculus, whether you're doing that on the STEM side or the business side. So I need you to know this formula. Again, we're just learning it, so I'm going to put it on the slides, but make sure you have it memorized. As you go through the homework, if you use it enough, you're gonna end up just memorizing it as long as you do enough problems, just naturally. So, all right. So here what we got to do is we see the formula over there on the right, and I've got A is the coefficient in front of the x squared, b is the coefficient in front of the x, and c is the constant. So I just copy down the formula. Everywhere I see a b, I put a 9. Everywhere that I see, well, here's another 9. Anywhere I see an A, I put a 2. Anywhere I see a C, I put a 10. And we have 2A in the denominator, so 2 times 2, since my A is 2. And then really it's just a matter of simplifying. So x is negative 9 plus or minus the square root. 9 squared is 81. And then if I do 4 times 2 times 10, that gives me 80. And then, of course, 2 times 2 is 4. So I just keep going here. Negative 9 plus or minus the square root of 1 all over 4, which is, of course, negative 9 plus or minus 1 over 4. But at this stage, it's important to remember, what is this plus or minus all about? It means there are two different answers, right? There's x is equal to negative 9 plus 1 over 4. And x is equal to negative 9 minus 1 over 4. So we get negative 2 and negative 5 halves as our two answers. All right, here's another example. Okay, so we've got it in that form, ax squared. Okay, now what I'm going to do this time, I'm going to be a little more careful rather than just pointing arrows at things. I'm going to actually list out A, B, and C. All right, and there's going to be a reason I do that. This quadratic formula is based upon this format right here, right? It's got to be in this form. So A, of course, is 2 because that's the coefficient in front of the x squared. But I'm supposed to be saying plus bx. So since there's a minus 6, we have to understand that b is actually negative 6 in this example, and then c is positive 3. Okay, so watch out for that. Plus b, so that's the same as plus negative 6. That's why b is my negative 6. Another thing to be careful of is when I go to plug this in, this negative right here is part of the quadratic formula. So I'm going to say negative b. Well, b itself is a negative number, so I'm going to go ahead and put parentheses negative 6, right? This negative being from the formula, and then b is negative 6. So watch out. It's easy to drop one of those negatives on accident. Make sure they both make it in. And then b squared, so negative 6 squared minus 4 times a times c, all divided by 2a. Now we know that the opposite of negative 6 is just 6, so that can be positive. We also know that when we square that negative 6, we get positive 36. And 4 times 2 times 3 is 24, all over 4. So we have a 12 under the square root, and we have a 4. Now, with our work with radicals in the previous chapter, we know that if a radical, and specifically the radicand inside the radical, has perfect square factors, we want to pull those out. So the same applies here. 12 definitely has a perfect square factor, right? Since 12 is 4 times 3. So I would end up with 6 plus or minus. Now that square root of 4 becomes a 2. And then the 3 is left under the radical. And so we have this. And then finally, there's just a little bit more simplifying that can be done, right? The way that I tend to like to do this is to just simply say, I'm going to take the two different terms on top and then just divide them both by 4, just like that. And then it becomes easy to see that a little bit of simplifying can be done, right? 4 divided by 2 is 2. 6 divided by 2 is 3. 4 divided by 2 is 2. 2 divided by 2 is 1. So with that simplification, I can now say x is equal to 3 halves plus square root of 3 over 2, or 3 halves minus the square root of 3 over 2. So both of those are solutions to that equation. All right, here's another example, but in this one, they do not give us the equation in the form that we need, right? We need it to look like this in order to apply the quadratic formula. This one's nowhere near looking like this. So you always do whatever you've got to do in order to make it put into that form ax squared plus bx plus c equals 0. So here, I'm going to have to FOIL all this out, right? So x squared minus 3x plus x minus 3 is equal to 2. Subtract 2 from both sides, so we have x squared minus 2x minus 5 is equal to 0. Now it's in the form that we want it in, and we can list a. Of course, if there's no number out here, we know it's really a 1 that's hiding out. B is -2, and C is -5. So solving this using the quadratic formula means taking -b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. So the opposite of -2 is 2. And then when I do this, it'll be -2 squared is 4. -4 times 1 times -5 would be +20. So x is equal to 2 plus or minus the square root of 24 over 2. But as always, we're going to look for perfect square factors inside of that radical. So 2 plus or minus 4 times 6. So x is 2 plus or minus 2 root 6. So x equals 1 plus or minus root 6. And it's fine if you write that. If you write this on an assessment, I'm okay with that. The last couple I have written out separately, right? Now this one I definitely want you to write out separately since they're both nice numbers, right? But this one, I wrote it out separately to really emphasize these are two distinct solutions. Here I did plus or minus. As long as you understand that those represent two distinct solutions, then that's fine if you leave it that way. All right, now my goal here is to just kind of quickly go through a tour of things that we should consider whenever we end up using the quadratic formula. Okay, so while the quadratic formula is really nice, you can see that it's not all just automatic. Um, Aside from the fact that you got to simplify correctly, there's also the idea that we saw here that they don't necessarily give us the equation in the format we needed at the beginning, right? So we had to force that to happen. In this one, there's a consideration, and that is it would be fine for me to let my A be 3, my B be negative 24, and my C be positive 24. That would be okay. That wouldn't be a problem. However, if you notice that you can factor a common factor out of all of the terms, you should take that opportunity. And the reason you should take that opportunity is because that will make the numbers that you're going to plug in to your quadratic formula that much smaller. Because if I factor that 3 out, then I'm also then allowed to divide both sides by 3. And the reason that's so advantageous is because the right side is 0. Um, it essentially has the effect of me just being able to get rid of the 3 altogether. So now I can apply the quadratic formula to these much smaller numbers, which is going to be really nice. So I'm going to let A be 1, B be negative 8, and C be 8. So X is equal to the opposite of B plus or minus the square root of negative 8 squared minus 4 times 1 times 8, all divided by 2 times 1. Now, this would be a good time to just pause the video, try to simplify this completely yourself. See how you do with that. And then unpause and let's make sure we get to the same thing. Okay, so I get X is positive 8 plus or minus the square root of 64 minus 32, all divided by 2. X is 8 plus or minus the square root of 32 over 2, but I recognize that 32 has a perfect square factor of 16. So this is 8 plus or minus 4 root 2 over 2. Break that apart. So X is equal to 4 plus or minus 2 roots of 2. Here's another thing you could run into. You might have fractions. Okay. Now, is it okay if you would like to plug 1/6 in for A, negative 1/2 in for B, and negative 1 in for C? Sure, you can do that. But you can imagine it's going to get pretty ugly. So remember that we also have a tool at our disposal. Anytime we see fractions and we don't want them, we've done this many times now, we can always multiply by our least common denominator. So I can look at this and say my least common denominator is 6. So I'm going to take 6 over 1 and multiply on the left by 6 over 1. And of course, I'll do the same thing on the right side, but again, because there's a 0 there, it's not really going to do anything. So I just end up multiplying everything by 6 on the left side. I can just say 6 there. So a little bit of reducing. And then this becomes a 3. So we end up with x squared minus 3x minus 6 equals 0. All right. This might be a good place to pause, apply the quadratic formula to this, see if you and I come up with the same thing. So I get A equals 1, B equals negative 3, and C is equal to negative 6. So X is equal to the opposite of negative 3 plus or minus the square root of Negative 3 squared minus 4 times a times c all over 2a. So 3 plus or minus square root of, so we'll have 9, but then negative 4 times 1 times negative 6 is positive 24. And to be honest, here's one of those problems where we're kind of relieved when we look at the number 33 and notice I don't see any perfect square factors in there. We're kind of relieved because then it's less work for us to do, right? So this is our answer, right? And if you wanted to write it out separately, that'd be fine. Right, there's one solution, and then here's the other solution. All right, so here's an example that's pretty straightforward looking. There's not a lot of special things we have to do on the front end. Seems reasonable just to dive right in and say that our A is equal to 4, our B is equal to 12, and our C is equal to 9. So that's just fine. So X is equal to negative 12 plus or minus the square root of 12 squared minus 4 times A times C, all divided by 2 times A. Now, as I do the simplification here, I get 12 squared is 144, but then 4 times 4 times 9 is also 144, so I'm just subtracting 144. So this ends up being negative 12 plus or minus square root of 0, right? So what happens here is we just get negative 12 over 8, which I guess I could simplify, right? Which I should do. So we'll say it's negative, sorry, try that again. Divide by 4 on top and bottom, and we get negative 3 over 2. All right, just one answer. Just one answer. Now, what's going on here? Well, we've seen situations before when we have a quadratic equation that only has one answer. And in fact, we can recognize that process if we take this equation and note that it actually is factorable. So if you try to factor this, it turns out if you go 2x plus 3 in both parentheses, and then you check 6x plus 6x is 12x, that works. So what happens is when you factor it, you get the exact same factor twice. And so, of course, both of those factors produce the same solution. So that's why when we use the quadratic formula, of course, we're going to get the same thing, just a single solution. All right, now there's two more examples here. And my purpose in these last two examples is to contrast the instructions in particular. All right, so on this first one, notice it says find any real solutions. Okay. And this one doesn't make any kind of specification like that. It just says solve. Okay. So going back to this one, and ooh, there's a little typo here. Excuse me. This should say equal to 0. I'm going to fix that for future sets of notes. But so you'll probably be looking this and see equals 0. But if your paper doesn't, make sure it says equals 0 right there. So find any real solutions to 3y squared plus 6y plus 5 is equal to 0. Okay, so I can see that A is 3, B is 6, and C is 5. So I go ahead and I plug this in. So negative 6, again, negative 6, plus or minus the square root of 6 squared minus 4 times 3 times 5, all divided by 2 times 3. So as I do this simplification process, 36 minus 4 times 3 times 5 is going to give me 60 all over 6. So this is negative 6 plus or minus square root of negative 24 over 6. Now let's just stop right there. We know that taking the square root of a negative is not a real number. Okay? That's what produces imaginary numbers and therefore complex solutions. So since the instructions on this problem were to find all real solutions to this equation, I am going to stop at this point and just simply say there is no real solution. So sometimes, as you're working through your homework, the instructions will specifically say find any real solutions to the equation. And if you run into the square root of a negative, then you just stop and say no solution. However, let's look at this example. No such distinction was made. They didn't say find all real solutions. They said solve it. Right? They didn't specify what kind of solutions they wanted. So I'm going to get everything onto one side here. Okay. And this is a great opportunity to talk about making life easier on yourself. Do you see how my natural inclination here was to subtract x from both sides? And that makes sense because I only have one thing that I would have to move off the left side to make it equal to 0. Okay. But then notice every single thing has a negative. So what may be a good idea here is to, instead of moving everything to the right side, if I moved everything to the left side instead, then everything gets to be positive. So I'd end up with 4x squared plus x plus 4 is equal to 0. I think I like the look of that better. So this is not incorrect over on the left, but it's a little harder. So I'm gonna go with the blue one. So A is 4, B is 1, C is 4. So we have x is equal to negative 1 plus or minus the square root of 1 squared minus 4 times A times C all over 2A. So this time, I also get a negative. 1 minus 4 times 4 times 4 is 64. So we get x is equal to negative 1 plus or minus the square root of negative 63 all over 8. Now, in the last problem, I quit at this point and I just said no solution. But the reason I quit was because the instructions said find real solutions. Here, they just want me to solve. So now, if the solutions happen to be complex numbers, we're okay with that. If imaginary numbers show up, we're okay with that. So we look at something like negative 63 and we remind ourselves, okay, what do I do when I have a negative under the square root? Well, I separate out the negative 1. And then while I'm at it, let's find any perfect square factors. Well, 63 is 9 times 7. And of course, 9 is a perfect square. So we end up with -1 plus or minus, and I'm just going to go ahead and break this apart one at a time, the square root of those individual pieces. So x is equal to -1 plus or minus the square root of -1, remember, becomes I. The square root of 9 becomes 3. And then the only other little adjustment I think is worth making here is that we want to remember that we like to put the number first, then the I, and then the root. So we'll say 3I square root of 7 over 8. So again, if I just say solve and you end up with imaginary numbers, I want you to give me a solution that has imaginary numbers in it. If I say find any real solutions and there's a negative under the square root, then you have permission to stop and just say no real solution.